Hello! In today's lesson, we will solve an example where we will apply the distributive property. The example looks like this. 7 multiplied by 0.5a plus 1 plus 1.5a and minus 9. And in this task, you need to find the value of the expression if a is minus 0.80. In the previous lessons, we talked about the fact that if we need to find the value of an algebraic expression, we can substitute that value into the original example. But in this case, we will need to perform many operations, and that's not a rational algorithm. So let's simplify this expression, transform it using our properties, and then find the value of the expression. We can see that in our example is written in parentheses. And then we can convert that expression using the distributive property. What do we need to do this? Well, for starters, I don't substitute a value equal to minus 0.80 in place of a. I'm going to start by transform this expression. What do we get as a result? Let's remember our rule. To do this, I'm going to multiply 7 by 0.5. 5.5a. A plus 7 times 1. And I'll rewrite the rest of the expression. Plus 1.5a minus 9. As a result. 7 times 0.5 tenths is 3.5 tenths a. 7 times 1 is 7. Plus 1.5.5a minus 9 equals 9. Let's continue to simplify this expression. What do we see? We see similar summons. These are those summons that are written with the same letter part. 3.5a's I can add 1.5a's. The result is that I get 3.5 tenths a plus 1 whole 5 tenths a is 5a's. 7 minus 9 are also similar summons. Although they don't have a letter part, they're constants, and I can add up these constants. Plus 7 minus 9. The result is minus 2. I got the following expression. 5 times a minus 2. And only now, instead of a, I can substitute the value minus 0.80. The result is 5 times minus 0.80 minus 2. 5 times minus 0.8 is minus 4 minus 2. And minus 4 minus 2 is 6. So in this, we've used the distributive property. We simplified our expression, and only after that we substituted the value of a equal to minus 0.8 tenths, and we found the value of our expression. Of course, if we had immediately substituted the value minus 0.8 tenths into the original example, we would also have gotten the answer minus 6, but that would be an irrational way of doing it. Let's solve another example. It looks like this. 4 times t plus y. Plus 5 times 2t. Minus y. Let's simplify this expression. Convert it. We write it without parentheses. To do this, we multiply 4 by t and multiply 4 by y. What is the result? 4 times t is 4t's. After this product, we must write down the sign. A 4 is a positive number. The number multiplied by plus y by a positive number is a positive. Lab product, 4y. Let's go to the second parenthesis. 5 times 2t. And notice, the number 5 is a positive number. and that's the number I'm multiplying by the positive product of two t's. 5 times 2 t's is 10 t's. Back to the number 5, it's positive. Plus 5. Well, let's write down plus 5. I multiply by minus y. The result is a 4 t's plus 4 y's plus 10 t's. Now we find the product of two multipliers with different signs. The number 5 is positive and y is negative. The positive times the negative is negative. The result is minus 5y. In order to write down the final answer, we'll find similar summands. 4 t's plus 10 t's is 14 t's. And 4y is positive minus 5y is minus 1y. You and I both know that. The quotient of 1 may not be written down, so I'm going to write down the final answer as 14t minus y. By converting algebraic expressions, by simplifying them, we can apply properties. These are the transpositional, combinatorial, and distributive properties, and then you'll get the right answer. And for today, our lesson has come to an end. Goodbye, see you again.